All right, so today we're talking about the properties of logarithms. So how can we use them to simplify logs, and then how can we use a change of base formula? So as a warm-up, pull out your calculator and type these all in and get some sort of answer. So you should get, switch colors, 1.176 and 1.176 and 2.708 and 2.708. So if you're looking at the pattern here, whenever you have two logarithms added together, that's the same as the log of their product. And when you have them subtracted, that's the same as the log of their quotient. So that brings us to the properties of logarithms. These are in your textbook, and you should memorize these because you're going to be using them a lot. So you want them to come quickly when you want to just know them instead of having to look them up all the time. So we already said the first two. You're multiplying, it adds. When you're dividing, you subtract. And then when you have a power, this comes down in front as a coefficient. So some examples. We want to rewrite these as a single logarithm with no coefficients. So if we look at this, we have log of base 2 of 80 minus log base 2 of 5. We write that as 1. We have subtraction right there. So this would be log base 2 of 80 over 5. And if you can simplify. So this one, you can divide 80 by 5. So this would be log base 2 of 16. The next one, we're adding, so we're going to multiply these. So you have log of x plus 2 times 3. Again, simplify if you can. So we have the log of 3x plus 6. This one, we want to get rid of that coefficient first. So we'll have the ln of 8x to the third to the 1/3. So this 1/3 is going to be distributed to both. So then we have ln of 8 to the 1/3 x to the 1. And that would be ln of 2x. Okay, so now a slightly more complicated one. I'm going to do this one in steps. So I'm going to start by bringing all of the coefficients up. So you'll have the ln of y to the third plus the ln of z to the 1/2 minus the ln of z squared plus 1 to the 4th. Now I'm going to combine the adding as multiplying and the subtracting as division. So we'll have the ln of y to the third, z to the 1/2 on the top, and all divided by z squared plus 1 to the 4th. You don't have to FOIL these out. If you really wanted to FOIL out z squared plus 1 and multiply it together 4 times, go ahead. You don't have to. You can just leave your answers like this because we got it all into one log. There's no coefficients and there's nothing easily simplifiable. Okay, so now we're going to the opposite direction. So we want to expand these to make them longer. So we want logarithms with no products, quotients, roots, or powers. So I can rewrite this one as the log of 5 to the 1/2. And I can bring that 1/2 down in front. So you have 1/2 log of 5. So now we don't have any products, we don't have any quotients, there's no roots, there's no powers. We're done with this one. Okay, this next one we're multiplying, so I'm going to split it up first. We have log base 5 of x to the third plus log base 5 of y to the 6th. Now I still can't have powers, so I need to bring those down in front. So you get 3 log base 5 of x plus 6 log base 5 of y. Now we have no products, no quotients, no roots, and no powers, so we're good. So again, a more complicated one. If we look at this one, I'm going to rewrite this first as a 1/2. So this is really the log of x plus 4 squared over x minus 1 all to the 1/2. So I'm going to bring that 1/2 out front. You could distribute it in if you want to. So we have 1/2. And then you can separate this into log of x plus 4 squared minus log of x minus 1 because of that division. Now, I'm going to bring this 2 down in front, so you will have 1/2 2 log of x plus 4 minus log of x minus 1, and I'm going to distribute in this 1/2 to both of my terms. So you'll get, these will cancel, and you'll have log of x plus 4 minus 1/2 log of x minus 1. So now we're down to no quotients, no products, no exponents, and no roots. And you're done. Okay, so we want to figure out what log base 3 of 12 equals, but the calculator only has a button for log base 10 and log base e, so how can you do it? Well, you can start by doing your loop, rewriting it as an exponent. Then I can take the log of both sides, and I divide by log of 3. And if you type this into a calculator, you'll get an actual number. You can do log base 12 divided by log base 3. So then the question is, well, what can I do for the next one? Like, what if I want to then look at log base 4 of 51? Do I need to go through the same process over again, or is there a simpler, faster way to do it? So we look at what we were doing here. We had log base 3 of 12, ended up being log of 12 over 3. So you could do the same thing here and have log of 54 over log of 4, and that will give you your answer. That process is called the change of base, or you're using the change of base formula. So what that means is if you take something here, log base b of x, you can rewrite it as log of the number divided by log of the base, as long as your new logs have the same base. So you could do like log base 2 of x over log base 2 of b. Probably won't help you much, but you could. So normally we do this one and just use log base 10 because that's what you have on your calculator. You also could do ln of x over ln of b, since you also have an ln button on your calculator. So if we're doing this, if you have a newer calculator, you might be able to do it by hand, but if not, this would become log base 20, or log of 20 over log of 9. Enter that into calculator, and you'll get 1.36342, because it's its 5th decimal place. And again, you could also do the ln of 20 divided by the ln of 9, and you'd get the same thing. Okay, so here, we're going to evaluate this 2 different ways, by applying the laws of logarithms and then by using the change of base. It doesn't really matter which one we do. The first step for both is to combine this into one log. So this is going to be log base 4 of 16, because you do 2 times 8, so log base 4 of 16. So if we apply the laws of logarithms, you can have this equal x. I'll rewrite this. You have 40 to the x equals 16, and you can get x equals 2. I could also just rewrite this as log of 16 over the log of 4. Type that in, and your answer will still be 2. So either way works. It's up to you which way you want to do. Here's your assignment, and a quick note here. So the answers in the back of the book aren't wrong, but they're a little bit more complicated. They go a little farther than we do for our purposes. So a quick example. This is one of your questions, and it says to write it out, so expand it like we've been doing. I would just do, and all you need to do, would do ln of 8 plus ln of x. The back of the book has 3 ln of 2 plus ln of x. Where that comes from is this right here could be written as the ln of 2 cubed, and then you can bring the 2 out front and you get this, and that just drops down. So this is fine. Check my key if you want my answers, but the back of the book might have little weird things at some point. All right, let me know if you have questions.